Hello, in this video I want to be covering solving literal equations, quadratic equations, and rewriting equations, solving by rewriting equations, and the examples from the ACT Prep. Here's the first one we have. It says solve for B2. Now, some people, whenever they're solving these equations, they like to draw a box or a circle around what they're solving for. And then they know that they have to undo everything on that side. So currently, the b sub 2 is being added to b sub 1 and then multiplied by b. So we have to undo that stuff in the opposite order. It's kind of like if you have a pile of dirty clothes, in order to get the stuff on the bottom, you have to take off the stuff that you put on last. So we're going to start by undoing the multiply by b first. So we do that by dividing both sides by b. And that cancels that out because when you multiply and then divide by the same thing, you get 1. So that's not going to affect our b1 plus b2, or b sub 1 plus b sub 2. So we've got 2a divided by b on this side. On this side, we now only have b sub 1 plus b sub 2. The only thing left to do is to subtract b sub 1 from both sides. When I say both sides, I mean both sides of the equal sign. So we get 2a over b minus b sub 1 is equal to b sub 2. Now we have it by itself, so we're done. All right, now in this one it says solve for d, and then it has what some students may recognize as a proportion. It has two fractions that are equal. Those students also may recognize that you can solve this by cross-multiplying and then solving. So when we do a times d, we get AD, and then b times c is BC. And basically what we did was we got d out of the denominator by multiplying both sides by d, and then we got b out of the denominator by multiplying both sides by b. Okay, so then our final step here is to just divide both sides by a. That will cancel that out, and you'll get d is equal to BC divided by a. All right, for number 3, this is our first quadratic. Now you'll notice we have some parentheses over here, and some students may recognize that you need to distribute this x in order to get the x's to where you can get them all on one side and solve this equation. All right, now what I'm going to use to solve all the quadratics is the quadratic formula. And it may look intimidating just looking at the formula, but there's several ways to remember it. The way that I tell students to remember it is by using a song. And that song goes to the tune of Pop Goes the Weasel, and it goes like this. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And that's the quadratic formula. We're going to use this formula to solve this equation. The first thing we got to do, though, is get this in standard form, which means we have to get it to look like ax squared plus bx plus c is equal to 0. We have to get it like this first before we can identify what a, b, and c are. So in order to do that, we got to distribute this x. So this side is just going to stay the same for now, 3x squared minus 12. And over here, we now have x plus 2x squared. So we got to get all this stuff over here on this side. And we do that by adding the opposite to both sides. In algebra, you can do anything as long as you do it to both sides. So if I subtract x from this side, I have to subtract x from this side. If I subtract 2x squared from this side, I have to subtract 2x squared from this side. All right, so now I'm going to combine like terms over here. 3x squared minus 2x squared is just x squared. And then there's no other x over here, so it's going to be minus x minus 12. On this side, these two cancel out, and I'm left with 0. So now it looks like this, so I can identify what a, b, and c are. Now there are other ways to solve this. If you know how to solve by factoring, go ahead and solve by factoring. This is a good one to do it. Your factors are 3 and 4. But like I said, I'm going to use quadratic formula because it always works. All right, so my a value is the value in front of x squared. If there's nothing there, then your coefficient is 1. Some students misinterpret that as me saying x is 1. I did not say x is 1. I said the number in front of the x squared is 1. Now the number in front of the x here, the coefficient for x, is negative 1. Again, since they don't actually have a number there, it's understood to be 1. And the reason why they don't put the number there if it's 1 is because when you multiply something by 1, you just get whatever you're multiplying by 1. So it's kind of pointless to write the 1 there. My c value for this is negative 12. So now I'm going to plug it into my formula. Okay, we've got the opposite of b. So since this is negative 1, that becomes positive 1 plus or minus the square root of b squared, so negative 1 squared, minus 4 times a, and a is 1, times c, which is negative 12, all over 2 times a, which is 1. Now, we now need to crunch the numbers on this. And the easiest way to do that is start with the stuff underneath the radical. This is the radical. This is the stuff underneath the radical. It's negative 1 squared minus 4 times 1 times negative 12. I do this first. That way it's a whole lot easier, in my opinion, to finish off this thing, if you know where to start. All right, this thing's called the discriminant, by the way. So negative 1 squared is 1. Negative 4 times 1 times negative 12 is the same thing as negative 4 times negative 12. So 4 times 2 is 8. 4 times 1 is 4. And since it's a negative times a negative, we have a positive. 1 plus 48 is 49. And this part right here, I'm going to plug back in where I took it out. So I'm going to plug it back in underneath the radical. So we get x equals 1 plus or minus the square root of 49 divided by 2 times 1 is 2. Now we know what the square root of 49 is. Square root of 49 is 7. So this is the same thing as 1 plus or minus 7 divided by 2. This symbol right here, this plus or minus, means that we have two different answers. One time we're going to add 7, the next time we're going to subtract it. So we've got x equals 1 plus 7 divided by 2, or x equals 1 minus 7 divided by 2. And now we can just crunch the numbers to finish the problem. 1 plus 7 is 8, divided by 2 is 4, so we get either x is equal to 4, or 1 minus 7 is negative 6, divided by 2 is negative 3. So x equals negative 3. And when we plug these numbers back into our equation, it should make it true. So if this is a multiple choice problem and you have answer choices, you can plug them in for x and see if it works. If it does, that's your answer. If it doesn't, then it's not. All right, this one's a little bit more direct. Let's go ahead and solve it. I got to get it equal to 0, just like my last one. So I'm going to subtract x squared from both sides. And I'm going to subtract 36 from both sides. And so we get 4x squared minus 36 is equal to 0. Okay, now you could use the quadratic formula on this one. I know I said I was going to use it on all of them. It's perfectly fine. Your a value is 4. Your b value, since there's no x, is 0. And your c value is negative 36. But a lot of students will recognize that, hey, there's a GCF here that I can factor out. And then, or you can say that you have dots, difference of two squares. Okay, so if you do the dots method, you draw your two sets of parentheses, and all I'm doing here is I'm factoring. So in dots, you take the square root of the first one, you get 2x squared, or 2x, and that goes in the front of both parentheses. You take the square root of the back one, which is 6, you put it in the back. One's positive, one's negative. The way that you recognize that it's dots is if both terms are perfect squares. 4 is a perfect square, x squared is a perfect square, 36 is a perfect square. The other thing you have to make sure is that this is in minus sign. All right, so now that I have two things being multiplied together to give me 0, if I have two numbers being multiplied together and it gives me 0, then one of the two numbers has to be 0. So either 2x plus 6 has to be 0, or 2x minus 6 has to be 0. Solve for x. So I'm going to subtract 6 from both sides in this one. So I get 2x is equal to negative 6. Divide both sides by 2. So I get x is equal to negative 3. This side I add 6 to both sides. So I get 2x is equal to 6. Divide both sides by 2. So I get x equals positive 3. So there's your two answers for this one. X equals negative 3, or x equals positive 3. All right, last one. This one's a little bit different. We have a radical instead of a squared part. So what we got to do for these, we have to get the radical by itself. So I'm going to start by subtracting 2 from both sides. So you get the square root of 3x minus 12 is equal to 3. To undo a radical, you need to square both sides. By squaring something, the square root of something, that pretty much just takes away the square root. You can think of it as canceling out if you want to. And you get 3x minus 12 on this side. On this side, we get 9. Add 12 to both sides. We get 3x is equal to 21. Divide both sides by 3. You get x equals 7. All right, there's these 5 problems. I'm sorry if it seemed a little bit rushed, but I wanted this video to be short. If you have any questions, feel free to comment or email me.